Hello students, I got few questions from a recent maths paper from a particular school. Let's solve this together. First question is a trigonometric question. Cos theta minus cot theta whole square is equal to, we have to prove that is 1 minus cos by 1 plus cos. So let's solve this. So cos can be written, cosecant can be written as 1 by sine, and cot can be written as cos by sine the whole square. The first and foremost logic here is you have to actually start solving the question based on what has to be proved or what is there in the RHS. So the right hand side is completely cos theta. Cos and sine can be related to the identity sine square plus cos square is equal to 1. So we are just converting cosecant and cot in terms of sine and cos. Now the denominator being same, I'm going to rewrite this as 1 minus cos the whole square by sine square. The power is now being distributed to numerator and denominator. And again, accordingly to the required proof, I'm changing this one step by step. 1 minus cos theta into 1 minus cos theta divided by 1 minus cos square theta. Sine square is 1 minus cos square from the identity. And so I'm going to use one more algebraic identity here. The numerator is the same, 1 minus cos theta and 1 minus cos theta. Denominator is a square minus b square, which is a plus b into a minus. Okay, so we are just cancelling this out, and we are able to prove the first question. It is so simple. Just have to convert in terms of sine and cos, and you have to use identities accordingly. The second one, find points on y-axis which are at 13 units from minus 5, 7. Okay, let's have a rough diagram here. Minus 5, 7. Let's locate it somewhere here. Find the points on y-axis. Points on y-axis can be anywhere because distance is 13 units. Maybe this is 13, maybe this is 13, maybe this is 13. Okay. So there seems to be multiple points from where the distance is measured to be 13 units. Let's find that. Any point on the y-axis is taken as 0, y. Okay. And the distance is supposed to be 13 units from this particular point, minus 5, 7. So let's use the distance formula. Root of x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to 13. Now, to just do the calculation part, we are squaring both the sides. So when you square it, the square root gets cancelled. So you have 5 square minus 5 whole square is nothing but 5 square plus 7 minus y the whole square is equal to 13. So 7 minus y the whole square is equal to 169. We are squaring this 169. 169 minus 25, which is 144. So as we are just squared both the sides to solve or get the value for y. Now we'll take square root both the sides for the same reason. 7 minus y is equal to plus or minus 12. This is one easy way of tracking this problem. Instead of expanding a minus b whole square, then you get a quadratic equation solved to get the same answer at the finally. So we have 7 minus y is equal to plus or minus 12. Don't forget to use plus or minus 12 because when we take a square root, two answers are possible. So 7 minus y is equal to plus 12 is one answer. 7 minus y is equal to minus 12 is the other point on y-axis. So now just solving this, y is equal to minus 5 and y is equal to 19. So these two are the points from which the distance measured to the point minus 5, 7 was 13 units. It's very simple, just using the distance formula. And the third question here, alpha and beta zeros of a particular equation. Find the polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. So how do we normally do such problems is just get the sum and product from the given equation. So alpha plus beta is minus b by a, which will give you 5 by 2. And product of the roots alpha beta is equal to c by a, which gives you 7 by 2. Now the question you have to clearly understand, find a polynomial, find an equation whose roots are this and this. So considering this to be the new alpha and this to be the new beta for the required equation. So what you have to do, to get an equation, we have a formula x square minus sum of the root x plus product will give you the required quadratic equation. So this is your alpha, this is your beta. So let's find the sum and product of these particular roots. So 2 alpha plus 3 beta. Alpha plus beta will give me 5 alpha plus 5 beta, which is 5 times alpha plus beta, which is 5 by 2 from the present equation. We just found that, so this is going to be 25 by 2. Sum of the roots which we are going to put in here is 25 by 2. Now let's find the product. 2 alpha plus 3 beta multiplied by 3 alpha plus 2 beta. So we'll just use the distributive and expand this. This is 6 alpha square plus 4 alpha beta plus 9 alpha beta. I'm clubbing that together. That's 13 alpha beta plus this will give you 6 beta square. So I'm taking 6 common, alpha square plus beta square from the first and last term, and 13 alpha beta. I have the value of alpha beta, which we got from the first equation, that is 7 by 2. So I can substitute that here right away. But what about this alpha square plus beta square? Or let's call it a square plus b square. We have, this is a special root identity. Alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta derived from a plus b whole square. So we will use that here. Again, we have sum square minus 2 product. So alpha square plus beta square, I'm replacing like this. And I have the 13 alpha beta untouched here. So let's substitute the values here. 6 times alpha plus beta is 5 by 2. So this is 5 by 2 the whole square minus 2 into 7 by 2 is the product plus 13 into 7 by 2. So I'm exactly replacing the right values, and let's find out what the product of the roots will be. So 6 into 25 by 4 minus 7. As these two will get cancelled, plus 91 by 2. So I have 6 into 25, take LCM 25 minus 28, which is minus 3 by 4 plus 91 over 2. Now again, simplifying this is 3 times, this is 2 times. So it is 91 by 2 minus 9 by 2, which is 82 by 2, and that is 41. All right. So this is going to be the product of the required equation. The product here, which is alpha into beta. Okay. We got the sum and we got the product. Now let's find out what the equation is. X square minus sum of the roots was 25 by 2, 25 by 2x plus product of the roots, we just found out, that is 41 is equal to 0. X square minus some x plus product. You can also get rid of this 2 by taking LCM throughout, and this is the required equation from the given condition, and this question is also done. The last and final question here. ABC is equilateral triangle of side 8 centimeter. A, B, C are centers of circular arcs of radius 4. Find the area of the shaded ring. So firstly, we have to find the logical part of how to get this shaded area first. So the shaded area is actually formed between 3 sectors. If you guys can understand this, this is one sector, second sector, and third one. So the shaded region is just sandwiched between the 3 sectors. So the required area, the shaded area, can be found out using the logic equilateral triangle area minus 3 sectors. Okay, so this is how we can try and solve this. Every information is given. Equilateral triangle area formula is root 3 by 4 times side into side minus 3 sectors. One sector is, so this is equilateral triangle, so angle is going to be 60 degrees. Theta by 360 into pi into r square will give me area of sector. This for one sector, I multiplied by 3 here, which gives me for 3 sectors. So now substituting all the values, root 3 by 4 times side is 8 centimeters, so we get 64 minus, and let's cancel this out, 1 by 6. This also gets cancelled, 1 by 2, 1 by 2 pi into radius is 4, so we get 16. So this is going to be 8 pi, and this is going to be 16 root 3. 16 root 3. So effectively, the shaded region can be obtained by subtracting the 16 root 3 minus 8 pi The values are given. Root 3 value is 1.732, pi is 3.94. If you put that all here, you get 2.59, correct, to two places decimal. Don't forget to write the unit, which is centimeters square. Hope this is very useful. See you all soon with another video. Take care. Bye bye.